All right, so let's go ahead and talk about all of our trig identities that we are going to learn. So very first thing in here, it says, let's go ahead and think back to your geometry days. And what is the equation of a circle with the radius of 1? If you recall, we have the equation for a circle should be x squared plus y squared is equal to, and it's typically r squared, so whatever your radius is squared. So therefore, if it has a radius of 1, it would be 1 squared, which is just 1, okay? Now, so far, we also have done a lot of things with our trig, and we know when you're going around the unit circle, for example, all of your x coordinates and y coordinates, right? So x is represented by cosine, and y is represented by sine, right? So let's go ahead and replace those into that equation that we have right there. Instead of x squared, we're going to do cosine squared. So typically what you would see written would not quite look like this, but I'm going to go ahead and show you. Oops, not equals. I would say equals to 1. Now, using trig, we typically don't see cosine squared written like this or sine squared written like this. Instead, what we typically see would be cosine squared theta or cosine squared x. It's written like this. These are equivalent statements, how these are written right here. Otherwise, if you put the squared at the end without parentheses, you're just saying that you're squaring the angle measure. And that's not what we're doing. We're squaring whatever cosine, whatever the angle is, and we're squaring that. So like say, for example, this, you know, if you were at pi over 4 and I asked you what is the cosine there, you should say back square root 2 over 2. If instead, if I wrote that as cosine pi over 4 squared, well, that's just squaring that pi over 4. And that would turn that into pi squared over 16. That's not what we're looking for here. So anytime that you have something written as squared between the cosine and the theta, that's what this is doing. It's taking the entire measurement for that angle and its cosine or its whatever its trig function is and squaring the value that you get back. Now, this is known as our original, the main Pythagorean identity that you have. You're going to have a total of 9 Pythagorean identities that you should know forwards and backwards. It's just taking this original one and doing a little bit of tweaking to it to get all 9 of them. So let's go ahead and do that. So the very first thing that I could do is I could go ahead and solve this equation and go ahead and solve it for cosine. So if I did that, that means that I'm getting cosine by itself, and I should say cosine squared. So that just means instead that I'm going to rewrite this by getting that sine squared over to the other side. And so now I have cosine squared theta is equal to 1 minus sine squared theta. Well, there's 1. I could do the exact same process, except instead of solving here for cosine, what if I solved instead for sine? So that means getting the sine squared all by itself. So that means then that I'm going to go ahead and bring that cosine squared over to the other side. And if I did that, then I would just have sine squared is equal to 1 minus cosine squared. And this is going to be 2 ways to rewrite your Pythagorean identities. So we're going to have that first one as our original one. We now have this one set equal to cosine, and then we also have this one set equal to sine squared. So those are 3 different ways to write the same equation. And then now I'm going to take this information and we're going to redo the same exact thing, but we're going to do a little bit of a twist to it. All right, so now what we're going to go ahead and do is we're going to take that original equation, and instead of solving for cosine squared or sine squared, instead what I'm going to do is I'm going to take all of my 3 terms and I'm going to divide all of them by cosine squared, and I'm going to simplify it down to see what that actually equals. So let's look at that. If I have cosine squared divided by cosine squared, well, anything divided by itself cancels out, but it doesn't just go away. It equals 1. And now we should know that sine divided by cosine is tangent, right? So sine squared divided by cosine squared gets me tangent squared. And then I've got 1 over cosine squared. We should know that 1 over cosine is secant. So 1 over cosine squared is going to be secant squared. Well, there's one of our other new identities that we've got here. And then I'm going to do the same thing that I did before in terms of rearranging it and solving for different parts of the equation. So instead here, if I solve this equation that I have written here for tangent squared, that just means that I'm going to subtract 1 from both sides. And that's going to go ahead and get me tangent squared theta is equal to secant squared minus 1. That's going to be another one of my equations. And then I can do the exact same process, and instead of solving for tangent squared, I just solve for 1. So that means then that I'm going to bring that tangent squared over here to the other side. And if I do that, it's going to cancel out over here. And now I'm going to have 1 is equal to secant squared minus tangent squared. Okay. So that's going to get me my 3 new different ways to write the exact same equations. So here's my 6 equations. And then now I'm going to go ahead and I'm going to do the exact same thing here, except instead of dividing everything by cosine squared, instead I'm going to divide everything by sine squared and then reduce. So let's go ahead and do that. So if I do cosine squared divided by sine squared, I should know that cosine over sine is cotangent. So if I go ahead and do this one, that's going to get me cotangent squared theta. And then I've got sine squared divided by sine squared. So just like cosine squared divided by cosine squared, anything divided by itself cancels out and it gives me 1. And then I should know that 1 over sine is also going to go ahead and get me cosecant. So 1 over sine squared gets me cosecant squared theta. So then that's going to be another one of my identities. And then the next thing that I need to do is exactly like what I just did before. And I'm just going to solve for both sides here, or both terms on the left here. So if I go ahead and subtract cotangent squared from both sides, for example, if I do that, then that's going to cancel out here, and that's going to get me that 1 is equal to cosecant squared theta minus cotangent squared theta. And then I can do the exact same thing, but instead of solving for 1, if I solve for cotangent squared, then I'm going to subtract 1 from both sides. And then I will get cotangent squared theta is equal to cosecant squared theta minus 1. And that's going to be my last of my 9 Pythagorean identities. So here's all 9 of my identities. So you can do it the way that I just did it, or you can also do each one of these. So like, let's take a look here. If I take all of my first 3 identities, and instead of rearranging them each time, and I just take all 3 of these, if I divide all 9 terms, so all 3 terms in all 3 equations, then I can go ahead and reduce them down if I go ahead and divide. So let's see, if I divide all by cosine squared, then that's going to go ahead and get me my first one. So if I go ahead and divide cosine squared, sine squared, and 1 by cosine squared, then that's what I'm going to go ahead and get there. So we'll do that in that order. So we do 1 by that, and that's going to get me equation 4. Okay. And then if I take equation 2 that I've got right here, if I divide all of those by cosine squared, then I will go ahead and I'll get equation 6 that I've got right here. And then likewise, if I go ahead and take equation 3 that I've got right here, and I go ahead and reduce that down, divide everything by cosine squared, then that's going to go ahead and match with equation 5 right there, okay? And I can do the exact same thing where if I go ahead and I take all of my original equations that I have up here in this first one, and instead of dividing by cosine squared, If I take each one of them and divide all three equations, oops, divide is spelled with an I there. If I divide all three equations instead by sine squared, then I'll get those other three equations down there. So if I divide my first equation, oops, if I divide equation number 1, every single term by sine squared, then I'm going to go ahead and get equation 7 down here. Okay. Likewise, if I go ahead and divide equation 2 by sine squared, then that's going to go ahead and that's going to get me equation 9 over here. So let's do that. Equation 2 will get me equation 9 by sine squared. And then if I go ahead and I take equation 3 that we have there, if I do that, that's going to rearrange and that's going to get me equation 8. So those are the two different ways that you can go ahead and you can get all 9 of your trig identities by just rearranging and dividing things. So go ahead and make sure that you understand where each one of these comes from. If you don't, then we definitely need to make sure that you get these because these are very, very important, okay? Now, in order to solve our trig identities or simplify or even verify anything with trig identities, we have to also know our reciprocal identities. And then we're also going to talk about, in coming videos as well, we're going to talk about our sum and difference identities, our double angle identities. We also know our quotient identities. So let me go ahead and write those down so that we can have those as well. All right, so here's where we've got all of our reciprocal identities. That's what I was mentioning earlier when I said, we should know that cosine divided by sine would be cotangent, and tangent is sine over cosine, and sine is 1 over cosecant, and all of those things. We should know these various different things right here. So the reciprocal identities is just stating what the reciprocals are of each thing. So sine is cosecant. They're just reciprocals. Same thing, cosine is the reciprocal of secant, and tangent is the reciprocal of cotangent. For the sake of doing things with identities, you will occasionally use your tangent and cotangent reciprocal identities, but you won't use them very frequently. Instead, what you're going to end up using way more frequently when it comes down to tangent and cotangent will be these, our quotient identities. So saying that tangent is equal to sine over cosine and cotangent is equal to cosine over sine tends to be way more helpful for this portion of the unit and things doing anything in that aspect. So these are all of the things that you're going to need to know in order to successfully do Unit 3.12. So definitely make sure that you have all of these down, okay? And in the next video, we'll go ahead and we'll work on utilizing all of these and seeing what in the world to do with these.